we're gonna look at all the houses that integrals have, the properties of integrals. We're gonna look. That doesn't make. It's a joke. It's a bad one. The properties of integrals. What does this mean? Well, first of all, I want to just say what I said yesterday. First, we have a definite integral. That means you have limits of integration on there. And A and B are called the limits of integration. The function on the inside, that's called the integrand. It's great. It's grand? Okay. And the dx part, that's just saying with respect to x. You're integrating with respect to x. So what does this mean? What does this mean? This means the area between the curve and the x-axis, and the curve that I'm talking about is f of x. So that's what the integral represents. A picture. We have picture. We make picture. So if we wanted to draw what this looked like, we'd have some curve f of x, and it's just the area between that curve and the x-axis. If you have area that's below the x-axis, it's a negative area. Yeah, so that's pretty much it. We're not going to know how to evaluate this algebraically yet. We're just thinking about the concept. This is the most important thing to remember. Just like it's another tattoo on your brain. All right. The derivative gives you a formula for the slope of the tangent line to a function. The integral gives you the area between the curve and the x-axis from A to B. So, yeah, let's look at some properties of the integral, huh? First, just like when we take the derivative of something, if there's a constant times a function, we can take the constant out. So if I had, if I had some constant, the integral from A to B of some constant c times f of x, the x, that's the same thing as taking this constant and putting it outside. So let's take a what would that look like? That would look like c times the integral. So you get the area and then just multiply it by c. It's the same thing. Just kind of like the same way we did derivatives. So that's the first property. Little example. I'll just say the integral. That's weird. So if I had something like this, where my function, my f of x is just x squared, and I have a constant multiplied out in the front. The integral of this is the same thing as the integral from -2 to 1 of x squared dx, and then you just multiply by 4 in the front. It's the same thing. That's all it means. So there we go. That's that first property. You can take out constants and just multiply your area at the very end. Remember, this would be the area underneath x squared and the x-axis, or just trapped between x squared and the x-axis, between the values, x values of -2 all the way to 1, and then we'll just multiply by 4. That's what that means. Okay, that's very good. We move on, huh? Yes. So what if I have, it's the same idea as the derivative. If you're taking the derivative of like a polynomial or something where you have addition in the middle, that's just like taking the integral of each of these separately. So this would be f of x dx, taking that integral and then adding it to the integral. Same limits of integration. We're using the vocab. G of x dx. And if you have this, then you could go backwards also, if you wanted to. So, yeah, if you have two things added together, you can take the integral separately and just add the areas separately. So what is that little example? What does that look like? Huh? Well, I'll show you. So, like, if I have this, maybe you should pause it and try to see what it would be. If I have just a polynomial or any two functions added together, it could be like x squared plus cosine of x or whatever. This, I can split up the integral across the addition. It's actually subtraction as well. Maybe I'll do plus or minus. And it's the same way. So like here, maybe pause it and try it. See, oh no! Ah! Almost had a heart attack. Almost died. Live on the video. That's not live. Whatever. If you die, live on the air. That's fun. That's because you're dead, and that's okay. Like if you're on like TV, like live TV, but then you die. It's kind of like a whatever. So that you could just split up the integral dx, and then have that addition sign, 1 and the 7 and then the 3x. Oh look, we could actually use the property here where we just take the 3 and put it out front, right? Because that's the other property. But there you go. That's what that means. Hopefully that makes sense. So we got those two properties. Yeah. Now take a look at this. The next property would be if you're integrating from A to A. If you think about the concept of this, this is saying what's the area underneath the curve. Say we have a curve. Whee! And we're taking, that's A value, the A value. This would mean the area underneath f of x, if this is f of x, the area underneath this, or between that curve and the x-axis, from A to A. That means from here all the way to there, same point. So like, what is the area of a line with no width? There's no area. There's no area. You see what I'm saying? I can't hear what you're saying. Okay, that's all right. Whatever. So yeah, this would be 0. This would be 0. All right, this is the easy one. Hopefully it makes sense. If you have the same limits of integration on the bottom and the top, it means it's 0. I'm not going to write a small example for that because it should make sense. Hopefully. All right, cool. So we got what, 3 properties so far? Maybe I'll pause this. I'll do it in the next video to finish the rest of them.